Okay, so we're talking about volume still, and we have already talked about what happens when you rotate it around the y-axis and what happens when you rotate it around the x-axis. And I'm going to review a couple problems like that real quick. But then what I really want to talk to you about is what happens if you rotate it around a horizontal line or a vertical line. If it's horizontal, that would be like y equals a number, like y equals 2, y equals -5. A vertical line would be like x equals a number. And as far as the way things behave, this is similar to the x-axis because it looks like the x-axis. This is similar to the y-axis because it looks like the y-axis. Don't get confused with the fact that there is an x there. The x there just indicates what the line looks like, but it looks like the y-axis, and that's very, very important. We're going to do 4 examples first that are going to be really quick, but I just want to remind you about the x and the y-axis, and then we'll go into the new thing. So first of all, let's say that you have y equals 4x, x equals 1, and the x-axis. These are your bounds. I'm not going to spend a lot of time drawing. I am going to draw it, but if you need to practice that, then just pause the video and practice it. Make sure that you understand the picture. What I want to do is I want to go around the x-axis. That would be the figure that you're looking at. If you graph that, you'll find out that this is 1 and this is 4. I want to remind you that when we do this, we sort of think about what the radius is, because that's what goes in the function. So it's pi times the integral of something times something squared dx, because it's like pi r squared. Since it's the x-axis, this is an x. Your r here, because there's not a hole, because it's a cone, it's just going to be one thing squared. The radius is going to be from the function to where you're rotating. So in this case, it's just going to be a 4x. Alright, so here's another one. Y equals 4 times the 4th root of x, and y equals 4x. Those are the boundaries of what we're looking at. And so this is sort of the figure. It intersects at 1 and 4. And there's the picture. And again, I want to go around the x-axis. This particular thing has a hole. So there's that inside sort of cone that's cut out of it. So as I go around the x-axis, I know that it's going to be pi, it's going to be something squared minus something squared. It's still going to be a dx because we're going around the x-axis. On the previous problem, I noticed I forgot to put 0 to 1, and that's because we're going around the x-axis, so we use x values. In this problem, since we're going around the x, it's still 0 to 1. But our radius is a little different. We start off with the big one, the one on the outside to where you're rotating, and then that would be the curve, so it's 4 times the 4th root of x. And then we do the inside part, which is the line, so that would be 4x. Okay, let's look at a couple where you go around the y-axis. So here's the picture. The equations we're looking at, we're going to look at these similar equations for several problems. Y equals 4 times the 4th root of x. Y equals 4, and the y-axis, that's your boundaries. And since we're going around the y-axis, first of all, I'm going to try to figure out, okay, what does it sort of look like? It looks like this cone thing. There's no hole, so I know it's pi times the integral of something squared. Because it's going around the y-axis, it has a dy. Since there's a y there has to be y's there, and there has to be y's here. Alright, this is... Okay, so the y-axis, it intersects at 4. So this is going to be from 0 to 4 because we have to use the y-axis since we're going around the y-axis. And since what's inside of there, when you look at the radius, it's just from where you're rotating to 0. But because it's the y-axis, I've got to solve that for x. So I'm going to divide by 4 and then raise both sides to the 4th power. So this should be y over 4 to the 4th to the squared. Okay, one more on the y-axis. I tried to do one with a hole and one without a hole on both of them, just so that you would kind of be reminded about it. So it's this like cylinder with the cone cut out of it, sort of, if you want to think of it that way. It's y equals 4x, x equals 1, and the x-axis, that's the boundaries. And we're going to go around the y-axis again. Since we're going around the y-axis, there is a hole, because I got to take this cylinder, and then I have to subtract off the cone. So I know there's going to be a pi, there's going to be integral, something squared minus something squared, dy. Alright, the first thing squared is the cylinder. These are the same values as before. That's a 1 and this is a 4. So the cylinder is going to be a width of 1. And the cone is just going to be the function minus 0. So that's going to be, it's not going to be 4x. I started to do that, but the thing I can't do is because this is y, and because we're going around the y-axis, then I have to solve that for x like I did on the previous problem. So if y equals 4x, I'm going to divide by 4, and I get x equals y over 4. So y over 4 is what goes on my equation. And then this is 0 to 4 because, again, I'm looking at the y-axis. Hopefully those 4 problems you're familiar with. Now, we're going to look at what happens if you go around a different line. So, here's the picture. And the boundaries are y equals 4 times the 4th root of x. We're going to, like I said, we're going to use these for a while. Y equals 4 and the y-axis. And we're going to rotate around y equals 4. So it's this part right here, and we're rotating around y equals 4. As far as the picture goes, the picture doesn't really change. It's still this fancy cone thing with the curve. Now, I think it's really, really important to draw the radius. So I'm going to do that. Okay? Now, I know it's going to be pi, it's going to be an integral, one thing squared, and a dx. The reason I know it's dx is because I'm going around y equals 4, and if I look at y equals 4 up there on my picture, that looks like the x-axis. So I know it's going to be in x's. Also, this is 1, so this is going to be 0 to 1. So it has to be on the x-axis. Now, the thing that goes inside of here, I know it's just one thing squared because there's not a hole. I'm going to look at the radius and these points that I have on the radius. One of the points is on 4. The other point is on 4 times the 4th root of x. So on these problems, it might look a little bit more complicated because you might have something inside the parentheses where you're subtracting some things, but that's because the radius is different. If I just put 4th root of x in there, then the radius I would be looking at would be this radius from the x-axis. But I need the radius from what you're rotating around. And if you draw the radius, the places where those points are tells you exactly what to put in the picture. Alright, let's look at another one. Okay, this is still the 4 times the 4th root of x and 4x. And we're still going to rotate around y equals 4. Alright, so this one, I don't know what you call that, but there is definitely a hole. It's like a cone minus a fancy little cone in the middle of it. Again, we're going around something that looks like the x-axis, so I know this is going to be 0 to 1 because that's a 1. And I know there's going to be a dx, but because there's a hole, there's going to be something squared minus something squared. Alright, I'm going to draw my radius. Start on the outside and go to where you're rotating. So that first one is going to be the line and minus the 4, or the 4 minus line. It doesn't matter which one you put first because you're squaring it, and when you square it, it makes it positive. So I usually put what I'm rotating first, but it's okay to put it the other way. So 4 minus 4x. Alright, my other radius, it's still going around the 4, but I go to what the function is, which is the curve. So it's going to be 4 minus the curve. Again, if you will draw that radius, the points on the endpoints of that radius tells you exactly which things to subtract and in what order. And I never have more than 2 things to subtract as far as the squareds, or 2 things to subtract inside of the parentheses. Alright, one more around y equals 4. This one is y equals 4x, x equals 1 in the x-axis. And we're going to rotate around y equals 4 again. So here's the picture. Here's y equals 4. There's a 1 again. I know it's going to be pi. It's going to be 0 to 1. I know it's going to be a dx because y equals 4 looks like the x-axis. Alright, this particular figure is like a cylinder with the cone cut out of it. So I start off with the radius of the cylinder, which is from where I'm rotating to the complete outside. Alright, this is y equals 4, so I know that the cylinder is 4 minus 0, or 4 squared. And then I have to cut a cone out of it, so I know there's something else squared. And if I look at that radius, it's 4 minus the function, and then squared. Okay, let's look at what goes on whenever it's going around x equals 1 instead of y equals 4. So some of these pictures are going to look the same. Alright, so it's this part right here, and your x equals 1 is right there. So if I'm going around x equals 1, first of all, x equals 1 looks like the y-axis, so I know that, okay, this is 1 and this is 4. I know that this is going to be 0 to 4, and I know it's going to be in terms of y because the line I'm rotating around looks like the y-axis. And when I think about going around that line, it looks like a fancy cone. There's no holes, so it's just going to be one thing squared. Let's draw the radius. Start where you're rotating and go to the outside. You're rotating around 1, so it's going to be 1 minus the function. Now remember, these are y's, so the function has to be y, so I need to go up here and solve. Divide by 4, I get x equals y over 4. So this is y over 4 inside of the parentheses. So the two boundaries here are y equals 4 times the 4th root of x and y equals 4x. And we're rotating around x equals 1 again. Intersects at 1, 4. Alright, x equals 1 still looks like the y-axis, so I know this is 0 to 4, and I know there's going to be a dy. And if I think about it on this one, there's going to be a hole because there's something I need to subtract out, so there's 2 things squared. Alright, to find the radius, start where you're rotating and go to the outside. Alright, I'm rotating around 1, so it's 1 minus whatever the function is on the curve. Again, I need to solve that for x. I believe it's y over 4 to the 4th. And we'll go ahead and solve this one as well, so it's y over 4. So it'd be 1 minus the curve, which is y over 4 to the 4th. And then the second one, do the radius again from where you're rotating to the inside. So that is 1, and that is the line. So 1 minus y over 4. Okay, this is y equals 4 times the 4th root of x again, and y equals 4, and the y-axis, and we want to go around x equals 1 again. Okay. Pi integral 0 to 4 again, because I know that this is 4. dy on the end, because x equals 1 looks like the y-axis. Let's draw this radius. The radius from where you're rotating to the outside. That's just 1 minus 0, so that's 1 squared. And then where you're rotating to the inside, so that's 1 minus the function. And we already solved that earlier. It was y over 4 to the 4th. Alright, let's do some other functions, other than those same ones we've been doing. Number 11, let's say that we have y equals 4 minus x squared, x-axis and the y-axis, and we want to go around y equals 4. Okay, that figure looks sort of like this. Intersects there at 2 and there at 4. So if I'm going around y equals 4, looks like that. So you want to start off by trying to figure out, okay, x's or y's. Well, the line we're going around looks like the x-axis, so it's going to be 0 to 2. It's going to be x's. It's going to be a dx. And then I try to figure out, okay, is there a hole? And if I continue to draw this thing, it looks like there is a hole. It's some like cylinder with the fancy cone cut out of it. So there is a hole, so that means it's something squared minus something squared. So let's draw the radius. Start where you're rotating, go to the outside. So that's 4 minus 0. Or your 4 squared, you don't have to put the 0. And then start where you're rotating and go to the inside. So that's 4 minus whatever the function is that curve represents. Because we're in x's, then that's 4 minus x squared. Be careful right here. If you wrote without the parentheses 4 minus x squared, it would not be correct. You could write 4 plus x squared if you wanted to change the sign. But just be careful with that as you put it into the formula. Okay, on this next one we're going to use the same figure, same equations, except this time we're going to go around x equals 2. Okay, so we're going around this line here. So it's like a cylinder with a cone cut out of it again. Now, because we're going around an up and down line, that means we need to have y's in our equation. This is going to be 0 to 4. And there is a hole, so it's going to be something squared minus something squared. Let me write down what those equations were again, because we're going to need them. Y equals 4 minus x squared, and then the x and the y-axis. So let's draw a radius. Start where you're rotating, go to the outside. So that's 2 minus 0. If you just want to put 2 squared, that's okay. And then I want to go from where I'm rotating to the inside. That's 2 minus the function. Remember, we have y's here, so I need to solve up here and make it so I have y's. So subtract 4, divide by -1. You can make it negative y plus 4 if you want. And then take the square root. It is plus or minus square root, but because I'm looking at the quadrant 1, it's just the positive part. So this would be 2 minus the square root of 4 minus y. Okay. Alright, so we have x equals 3, x equals 1, y equals x squared, and we want to go around y equals 9. Here's y equals 9. Alright, because y equals 9 looks like the x-axis, this is going to be 1 to 3 because it's on the x. I know there's going to be dx's. It looks like it's going to be 2 things squared. So let's start from where you're rotating, go to the outside. Alright, this was a 9, so this is 9 minus 0. Start from where you're rotating, go to the inside, so that would be 9 minus, and then the function is x squared, and it's in x's because it's going around y equals 9. Last problem other than the try ones. Y equals the square root of x, y equals 0, x equals 4, and we want to go around x equals 4. Alright, it's going to be pi, it's going to be 0 to 1, because of this one, it's going to be dy, because the line we're going around is up and down, looking like the y-axis. It doesn't look like there's a hole, so it's just going to be 1 thing squared. Start where you're rotating, and go to the outside, so you're rotating around 1, so 1 minus the function. I can't put square root of x in there, because that's a y. So solve this up here. That would mean y squared equals x if you square both sides, so that would be a y squared. Alright, there's 4 problems I want you to do. The first 2 I just want you to fill in the blank. And do these on a separate sheet of paper. You don't have to write the whole sentence unless you want to, but I just want to know what the answer would be in the blank. If going around the y-axis or a line like x equals 5, values in the equation are in terms of blank. That would be either x values or y values. Number 2, if going around the x-axis or a line like y equals 3, values on the interval, that's talking about when you take your integral here, these interval values are blank values. X or y is the answer there. Decide which one it is. And then you have 2 problems to try. Both of these pictures are the same. We're using y equals x squared, x equals 2, and the x-axis as the boundaries. On number 3, I wanted you to go around y equals 4. And on number 4, I want you to go around x equals 2. And I just want you to set it up, figure out what it would look like set up. And if you want to go ahead and get the answer so we can check them, that would be great. See you tomorrow or Wednesday, whichever's first.